Hello, good evening everybody. Today we are going to study about a rectifier. A rectifier, it is a device which converts AC into DC. A rectifier converts AC into DC. All electrical devices works on AC and all electronics devices works on DC. For electronics devices, 5-volt DC supply is required. But in our home, there are AC easily available. So, a rectifier, it is a device which converts AC into DC, and that DC can be used for the working of semiconducting devices. There are two types of rectifier. First one is half wave rectifier, and second one is full wave rectifier. Let us draw the circuit diagram of half wave rectifier. Half wave rectifier circuit diagram is like this. Now in this circuit diagram, this is input AC supply, which we have to convert it into DC. This AC supply is connected to primary windings of the transformer. This is transformer. This part is transformer. Transformer is a device which converts AC into AC. Means given AC into required AC. Means AC is converted into AC. For example, 230 volt AC can be converted into 10 volt, 6 volt AC. Or 10 volt AC can be converted into 230 volt AC. So transformer, it is a device which converts given AC into required AC. If we require lower voltage, then we have to use step down transformer. And if we require higher output, in that case, we have to use step up transformer. This transformer is selected according to our use. Now, for half wave rectifier, step down transformer is used, which converts. In our home, 230 volt AC is available. This AC can be converted into DC, but before that, it should be converted from higher AC voltage to lower AC voltage. So this is transformer. This transformer works on the principle of mutual induction. What is mutual induction? That we have studied in EMI and AC circuit. Now this second part is, this is diode. Diode, it is a semiconducting device which consists of P-N junction. P-type semiconductor, N-type semiconductor fused together, then it forms a P-N junction. Now this terminal of diode is known as anode and this terminal is known as cathode. Now this RL is load resistance, which is connected like this, and output is taken across the load resistor. Now construction of this half wave rectifier is input AC, which is to be rectified, is applied to primary windings of the transformer. Then the secondary windings are connected to diode through load resistance, and output is taken across load resistor. This is construction of the circuit. Then now let us see how it works. During first positive half cycle, when S1 is at positive potential, S2 is at negative potential. Therefore, positive potential is given to anode. So this diode becomes forward bias. When diode is forward bias, it acts as a closed switch. Its resistance becomes low and large current flows through it. In ideal case of diode, forward bias resistance is 0. Practically it is 50 to 100 ohms. So during positive half cycle means S1 is at positive potential, S2 is at negative potential. This diode conducts. So current flows through this diode. Then current flows from A to B. So we get output voltage across RL. So in this way, for positive half cycle, diode conducts and we get output. During next half cycle, when this S1 is at negative potential and S2 is at positive potential, now this anode is connected to negative potential. So now diode is in reverse bias. In reverse bias, resistance of the diode is infinity in ideal case. So current cannot flow through this diode. So output voltage across the load resistance is 0 because current is 0. If we draw waveform of this circuit, this is input voltage and this is output voltage. Input is AC supply. Now during positive half cycle of AC, diode conducts and we get output. So during positive half cycle we get output because diode D conducts. During negative half cycle, when S1 is at negative potential, diode becomes reverse bias. So it do not conduct. Current through this diode is 0 and output is 0. So during positive half cycle it conducts. During negative half cycle it remains off. Again for next positive half cycle it conducts. For negative half cycle it do not conduct. So for each positive half cycle diode conducts and we get output. For each negative half cycle diode do not conduct. So we will not get output voltage. So full wave of input is given, but only half wave is converted into DC. So it is known as half wave rectifier. Now question will be like this. This is in this circuit current flows from A to B only, or current do not flow. So this output current is unidirectional. Output current is unidirectional. So this is DC. But this is not pure DC. It contains some AC part. So this is poor quality DC. It contains ripple. A ripple means AC present in DC. A ripple means AC present in DC. Ripple factor is 1.21. Means for example, if output voltage is 1 volt AC, it contains 1.21 volt AC. Means AC part is more than DC. So quality of this circuit is very poor. Sometimes question is, what is the ripple frequency? In our house, 230 volt AC is available and frequency of AC is 50 Hz. MCQ question will be like this. If input frequency is 50 Hz, what is the output frequency of half wave rectifier? In this case, input frequency is equal to output frequency, because to complete one cycle, this much time is required for the input, same time interval is required for the output. So input frequency is equal to output frequency. If input frequency is 50 Hz, output frequency is also 50 Hz. So, then question is, what is efficiency of the circuit? Efficiency tells us about the loss in the circuit. Now in half wave rectifier, efficiency is 40.6%. It means 50 negative, when negative half cycle comes, this circuit do not give output. So 50% loss is there only. To conduct the diode, for silicon diode, 0.7 volt is required. For germanium diode, 0.3 volt is required. Again, there are different losses in transformer. Due to that, total efficiency of the circuit is very low and it is 40.6%. Then, output voltage is equal to Vp upon pi. Vp means peak voltage. This is maximum voltage, which is known as peak voltage, and output voltage is Vp upon pi. Then output current is equal to IP upon. In this case, we should know all these properties of half-wave rectifier. These are the characteristic or properties of half-wave rectifier. So this is about half-wave rectifier, which in this case full wave of input is given, only half wave is converted into DC, so it is known as half-wave rectifier. This circuit do not give pure quality DC. It gives poor quality DC because this is not pure DC, it contains some AC part. That AC present in DC is known as ripple. So ripple is 1.21, output frequency is equal to input frequency, efficiency is 40.6, output voltage is equal to Vp upon pi, and output current is equal to Ip upon pi. Okay.